we are on page 29, wave behavior, Bellringer. We are looking for reflection, refraction, diffraction, or interference. Emily and Allison?
Reflection is the when the wave changes the direction of a wave when it bounces off a surface or object.
Yeah. So it's when a wave.
Are we working on week 3 or week 4? I'm so confused.
There is no Bellringer in your packet for this. This is just a review.
Oh, okay.
So it's when a wave changes direction because it bounces off a barrier. Excellent. Who wants to try one of the other three?
I do.
Okay, Charlie, which one and what's the definition?
Refraction.
Refraction?
Yeah, however you pronounce it.
Mm-hmm.
When a wave passes through a barrier,
Mm-hmm.
and they're into a new medium, such as air into water.
Okay, so it's when what happens when a wave changes mediums? Refraction is when a wave changes mediums.
The wave bends.
I'm sorry?
The wave bends.
Yeah, and it bends. It changes medium and that makes it bend in funny directions. Two more. Who wants to give him a shot? Grace?
I'm going to try diffraction when the bending of a wave when it passes through a slit or around an edge.
Yeah. When a wave bends.
Okay. Miss Dara, so I'm on the phone with Olivia because it still wasn't working through her phone or anything.
Okay.
So, Olivia, tell me if you can see this. I'm going to turn the camera around.
So it's when a wave bends because it is traveling through a slit. It's like a small hole, like a pinprick hole. Or around an edge.
You can just take notes on a piece of paper then.
Yeah.
That's the thing, I don't have any pieces of paper. I'll take it. Can you send me a picture like of yours?
I'm not working in my. No, wait.
Charlie?
Yes.
Tell Olivia that there will be a YouTube that she can look up.
There'll be a YouTube that you can look at.
All right. Last one is interference. This one is the weird one. This is the one that we can't like actually see. This is the one that we really can't visualize very easily. What is interference? No, Nathan, it is not just plain traveling. It's not just plain traveling. Emily and Allison?
It is a combination of two waves to form a result to wave of greater or lower amplitude.
Yeah, it's a combination of waves that have come together. And then, of course, this forms that resultant wave, that Franken wave that we talked about. So it'll look a lot like one wave, and I'm going to depict this as a transverse wave, but it'll look like one wave coming in contact with another wave to create one thing. Zep, what's a kind of wave that we've talked about that is two waves that have combined?
Electromagnetic?
Yep, electromagnetic waves. Part B, what is the difference between a reflection and a refraction? All right, Furman said, the difference between reflection and refraction is that one is bouncing and one is bending. One is bouncing and one is bending. There's a couple other differences. What's another difference? So of course there's the obvious, bouncing versus bending. Okay, so in reflection, a wave will bounce off of a surface and change direction.
Mister, I think I have one.
Okay,
I'll wait till you're done writing them.
alrighty. In refraction, a wave will bend because of a change in medium. But what else is changing in refraction? Emily and Allison?
Our hand was still raised.
Oh, okay.
Oh, no,
What else is changing? So refraction is happening because of this change in the medium. But this change in the medium, this is causing something else to happen, and this compounds the idea of refraction. This is compounding the effects that we see during refraction. B, you said direction, and that's an excellent guess, but direction is only a part of what's changing.
So the speed, a wave refracts because its speed changes in a new medium.
Right. Refraction occurs
When speed of a wave changes, the direction of the wave changes, and so it bends.
right. Okay, refraction occurs because the wave's velocity is changing. That idea, velocity is the idea of speed and direction.
Okay.
Forgot a very important word in our first sentence. Because IR engineer, not ELA teacher. All right, part C, very easy. Part C is very easy. We just gotta draw a picture.
That sounds very easy too.
We just have to draw a picture. Now, what we are gonna draw, the picture, the representation on the Bellringer is of a longitudinal wave. This is a representation of a longitudinal wave, okay? Now I know that this is a lot to write down, so I'm not trying to rush you. I'm just gonna set up the drawing for part C.
I'll be right back.
Okie dokie.
Can I go on page 30 for part C?
Sure. Now, we're going to talk about diffraction. Okay, because part C wants to know how might the following wave diffract as it bends to squeeze through this all opening in the barrier. And we're just going to draw a picture of what this might look like. So, yes.
My mom said that she needs me to finish something, so can I go?
Yeah.
Okay. Bye.
Goodbye. So, what are we going to see? So if this is a thick piece of paper, let's say, and this is I'm shining a light through it. Yeah? Or if this is a megaphone and I'm yelling through it, what's going to happen to the wave as it's traveling outside of this barrier, as it's traveling through this opening in this barrier? What do you think diffraction will look like? Now, some of us might think that it's just going to travel on through, no problem. Some might think that only this little section, this little bit, can fit through. Okay. But what's actually very interesting is that the whole wave is going to squeeze and shimmy its way through if it can, and that's going to result in a wave that feels a lot like it's arced. It starts with these short wavelengths, and then it spreads out until it has those longer wavelengths again. Another way that you can see this represented as, okay, so I'm going to draw this delineation, okay? I'm just drawing this line so you know I'm drawing two different pictures here. Another way that you can see this represented as is with curved lines. But you can see that our wavelength is getting longer. So this is the bend part of it, and this is the expansion part. So this is that bending as it's trying to squeeze through because the wave had to bend to get through that hole. Like a spaghetti noodle leaving through the holes in your strainer spoon.